Good morning, dear students. Okay, in the last class we discussed about uh, this undefined terms like a point, line, and the straight line, surface, plane surface, all these things in the Euclid geometry. These are the undefined terms in the Euclid geometry. And this chapter is completely more is a theoretical concept than the practical problems. So we have more theoretical things to learn in this. Okay, so now if we carefully studied the all this definition what we did yesterday, what we seen yesterday. So if we carefully study these definitions, you find that some of the terms like part, breadth, length, evenly, etc. need to be further explained clearly. The telling part, there is no clear explanation for that. So for example, considered is definition of a point. In this definition, a part needs to be defined. Suppose if you define a part to be that which occupies area, again an area need to be defined. So that the define one thing, you need to define many other things. So and you may get a long chain of definition without an end. So for such reason, the mathematicians agree to leave some geometrical terms undefined. So what happens, so it's become a chain link. Suppose what is here, suppose if we take this definition, a point, a point is that which has a no part. So okay, which has no part, what do you mean by part? Okay, if we define part, so then again one question arises. So like this, questions are keep on arising like a chain link. So to avoid this, what the mathematicians in the ancient period like Ptolemy, Euclid, and other Pythagoras, like that other mathematicians, what they did, they agreed to leave some terms as undefined. So they not defined then this terms completely. So such terms are here. So here the however we do have a initiative feelings for the geometrical concept of a point than what the definition above gives us. So we represent a point as a dot even though a dot has some dimensions. So here they discussed about the first definition, that is point. So in the point we not able to define the part, so they agreed with that and they take that as undefined. And similar problem arise in the definition 2. What is the definition 2? Definition 2 is a line is a breathless length. So while for defining this also, they find the define the difficulties of for defining. So what they did, because of this, a few terms are kept undefined. So few terms are kept undefined while developing any course of study. So in geometry, we take a point, a line, and a plane. In Euclid's word, a plane surface as undefined terms. Which are undefined terms in Euclid geometry? Here, a line, point, and a plane, or also you can call that as a plane surface. These three terms are undefined terms in the Euclid geometry. The only thing is we that we can represent them intuitively or explain them with the help of physical models. Okay, we can explain this. What is the what is that point we can explain like this. So it's a point. So this is a point we can tell, this is a point we can tell, this is a point we can tell, but we're not able to give a exact definition for that. And when you talk about the line, so we can tell this is a line, so this is a line, this is a line, this is a line, we can tell these are lines, but we're not able to define this exactly. Why? Because the chain link keep on going. So the mathematician decided to keep these terms as undefined. Okay, so the undefined terms in Euclid geometry are in the point, line, and plane. In the examination, the one more question may be appear like this: which are the undefined terms in Euclid geometry? The undefined terms in Euclid geometry are point, line, and a plane. Okay, and do one thing in the class. Okay, I'll tell you what to write in the classwork afterwards. Okay, so next. Okay, now the next, starting with this definition, Euclid assumed certain properties. Certain properties he assumed, which were not to be proved. Their assumption actually obviously truth. They divided them into two types, axioms and postulates. So dear students, you already learnt about axioms and postulate in your previous classes, that in the 8th grade. Okay, now just is a recalling of this concept, that concept what you learnt in the 8th grade. So here we know what is axioms. Axioms are certain elementary statements. It's a statements made by the mathematicians, and which should be accepted without any questions. Without any questions we should accept that. So they're telling that the things which are equal to the things which are equal to the same thing are equal to one another. You should not ask that why it is like that, why it is like that. We should not question it. So you should accept it as it is. What they're telling, we should accept it. So that is nothing but axioms. And even postulates also the same, is an elementary statement which are accepted without any questions. Without any questions we should accept that. So then what is the difference between axioms and postulate? So axioms are applicable to all the branches of mathematics and science. Axioms are applicable to all the branches of mathematics and science, but postulates are applicable only to the geometry. Postulates are applicable only to the geometry. So let's see this, what they gave here. Starting with this definition, Euclid assumed certain properties which were not to be proved. These assumptions are actually obvious universal truth. He divided them into two types, axioms and postulates. He used the term postulate for the assumption that were specified to geometry. Okay, common notions often called axioms, on the other hand, were assumptions used throughout the mathematics and not specifically linked to geometry. Okay, so the what I told, no, so that only they give here. So that is, axioms or elementary statements which are accepted without any questions. Okay, and it is applicable to all the branches of mathematics like geometry, what is that, arithmetic, algebra, like that. But postulates also elementary statement which are accepted without any question, but it is applicable only to the branch of only applicable only to the geometry. It is not applicable in any other part of the mathematics. Okay, so here, um, for details about axioms and postulate, refer. Okay, so some of the Euclid's axioms, they are given, they listed axioms according to the serial number. So first one is, things which are equal to the same things are equal to one another. So what is this definition? So I'll give an example. Now you may see here, uh, so I'm drawing a line here. Okay, and one more line here. So I call this as AB, and this is CD, and AB is 5 centimeter and CD also 5 centimeter. So therefore we can tell that if AB is equals to BC, AB is equal, we can write here AB which is equals to BC. Why? Because, sorry, not BC, what is it, DC or CD. So here you can write here AB which is equals to CD. The things which are equal to the same thing are equal to another. Why? Because here AB is also line segment and CD is also line segment, and AB is 5 centimeter and CD is also 5 centimeter. Okay, now suppose, can we tell this is equal? Suppose I draw a one line segment is lies this one, and here one line segment. So this is XY and this is PQ. Can we tell XY is equals to PQ? No, XY and PQ are not equal. Why? Because it is of length of, it may be length of 4 centimeter. Sorry, not 4, it's more than that. So it may be 5 centimeter. Okay, 6 centimeter, and it is only 2 centimeter. Both are equal? No, we can't tell. So but this we can tell. So this only they told that things which are equal to the same thing are equal to one another. So therefore here we can write AB is equal to BC. And now what is the next they are asking? This next they telling here, if equals are added to equals, the whole is equal. As we know, this in this example we can consider it. So here AB and CD are equal, 5 centimeters. Okay, now what I am going to do, so the same line segment, for the same line segment. So here AB, and again here AB. Okay, so here I have one more line segment. Okay, so this is AB, this is CD, and this is PQ. So now AB is 5 centimeter, CD is also 5 centimeter, and PQ is same to say that is 2 centimeter. Now what I'm going to do, I'm going to add this PQ to AB and CD. So already AB and CD both are equal. We know that both are 5 centimeters, and PQ is same. So what I'm going to do, so I'm going to add this PQ now. So this is PQ, and here also I'm adding PQ. So already AB is equals to CD. Now I'm adding here PQ and PQ on the both side. So what it become? So you can write here AQ, which is equals to here Q, right? CQ. You can write here AQ is equal to CQ. Why? Because now it is 2 centimeter, and this is 2 centimeter. What is 5 plus 2? 7 centimeter and 7 centimeter. So therefore, according to second statement, if already AB and CD are equal, for that equal we are adding a PQ 2 centimeter equal again. So equals are added to the equals, the whole is equal. So therefore, for the entire AQ is equal to CQ. Is it clear? Okay, now what they're telling in next statement, if the equals are subtracted from equals, if equals are subtracted from equals, the remainders are equal. If equals are subtracted from equals, the remainders are equal. Again we'll take the same line example. So here 5 centimeter, no, now we'll change the centimeters. Now it is 6 centimeter and 6 centimeter. I'll change the name here. Here PQ and RS. PQ and RS. So it is PQ is 6 centimeter, and RS is also 6 centimeter. Now what I am doing here, so I am cutting 1 centimeter on both the side. So what is the remainder? So again here 5 centimeter, and again here 5 centimeter. But that is the third statement. If equals are subtracted from equals, the remainders are equal. So therefore you meant to say this point is PQ A, and here is B. So already PQ is equals to RS. Now what I did, I removed AQ from PQ and SB from RS. So therefore you can write here PA is equals to RB. So if equals are subtracted from equals, the remainders are equal. Okay, fine. So next, the things which are coincide with one another are equal to one another. So what do you mean by this? The things which are coincide to the one another are equal to one another. Okay, I'll give an example. There's a square. Okay, now on this square, okay, I'll take another color. On this square, I'll draw one more square of the same length, same width. Now can you tell me which is greater? Here I have drawn two squares, one is blue and one is red. Can you tell me which is greater, which is bigger? No, both are same, right? Why? Because both are coincide. So which we keep one, we can match the one corner with the another corner of the square. So therefore the things which are coincide, they are coincide, they are closely completely packed here to one another. So therefore the things which are coincide to one another are equal to one another. So there is a definition. Okay, next, the whole is greater than the part. So now here is a square. In the square, what I'm going to do, I'll take a small part. Okay, I'm going to take this small part in this square. Okay, so I'll take this part, small part. So then which is greater? So the whole, the bigger one is a greater than the smaller one. Okay, so now the sixth one, the things which are double of the same thing are equal to another, the same thing. So here again we can take the line example only, it is the best. So here again 5 centimeter line. Okay, the things which are double of the same thing. So what I'm going to do here, AB is 5 centimeter. Okay, here AB, which is equal to 5 centimeter. So again what I'm going to do, take the again 5 centimeter, I double this, so then it become ABC. So therefore here AC is also 5 centimeter. So the things which are double of a same thing are equal to one another. So the same thing what we did in the first case, so we added, right? Sorry, in the third case, so we doubling here, doubling. Suppose here 5 centimeter is there, again we adding a 5 centimeter, so that entire thing will become same. So this is PQ, here it is 5 centimeter, and again I'm adding RS, yes, so this is 5 centimeter. So therefore this is also 10 centimeter and this is also 10 centimeter. So the same thing here also, the things which are half of the same thing are equal to one another. So when we cut, already a 10 centimeter is there, when you cut to the half of this, so it become half of that. Okay, so these are the axioms. So what we should do, we should accept without any questions. Is it clear? So axioms are certain elementary statements which are accepted without any question. This is the definition of the axiom, and it is applicable to the all the branches of mathematics like geometry, algebra, arithmetic, and all, and even in the some of the science also, some of the concept in the science also. Okay, so in the classwork you need to write this. Okay, copy these things in the classwork. So mention today's written day and write. So today this is a briefly I wrote what we and all studied today. So what is that? So through Euclid defined a point, line, and plane that definition are not accepted by the mathematicians. Therefore, these are known as an taken as a undefined terms. So this in the question in the examination in the for the 1 marks them as the question, which are the undefined terms in the Euclid geometry. So in the Euclid geometry, the undefined terms are is nothing but point, line, and plane. Okay, next, what are axioms or postulates? So axioms and postulates are assumptions which are obviously truth and do not have proved. So in the later classes, I'll give exact definition of the axioms and postulate and difference between axioms and postulate. So far, you should write like this. So write as a points: first point, second point, third point. And here theorems and other statements which are proved using definition, axioms, previously proved statements, and deductive reasonings. And in the Euclid's axioms where these are the important, so practice this and write this Euclid's axioms one time in the classwork and one time in homework book. If you are maintaining homework book, so write one time in the homework book. Okay, so the remaining thing we'll see in the next class. Thank you, have a great day.